Trunk muscle training describes exercise programs that focus on trunk muscles surrounding the axial components of the skeleton, irrespective of anatomical orientation and depth. Trunk muscles provide stability and act as a link between the upper and lower body, which facilitates effective transfer of movement during whole body activities, including sport performance, fitness training and activities of daily living. Consequently, the trunk has been described as a powerhouse due to its capacity to transfer, absorb and redirect kinetic energy. The effects of trunk muscle training on physical fitness and sport-specific performance in young and adult athletes has recently been investigated by Atle and colleagues. As the title suggests, their main aim was to examine the effects of trunk muscle training on physical fitness and sport-specific performance in healthy, competitive athletes. 31 studies with 693 participants aged between 11 and 37 years were included in their meta-analysis. Of the 31 studies, participant characteristics such as age, sex, and expertise level were analysed to determine the impact on trunk muscle training outcomes. In addition, training variables such as frequency, training period, session duration, and number of training sessions were also analysed to determine their impact on trunk muscle training outcomes. This presentation, brought to you by Talking Sports Science, will be a summary of their findings and recommendations. Firstly, performance and physical fitness results. There were moderate effects for trunk muscle training on sport-specific performance measures, such as throwing velocity, drive distance, and swimming time. Furthermore, there were small to large effects reported on physical fitness measures such as maximal muscle strength, change of direction/agility, and linear sprint speed. And moderate effects on trunk muscle endurance were also found when compared to control participants not completing trunk muscle training. Moving on to our second point, participant and training variables. Sex and expertise level did not influence trunk muscle training outcomes. However, participants' age significantly modulated on change of direction and agility, with a positive effect on trunk muscle training in children but not adolescents and adults. This may be a result of a potential ceiling effect for trunk muscle training, in that greater longitudinal exposure and higher volumes of training in older athletes may reduce the potential for trunk muscle training to influence sport and fitness measures. However, trunk muscle training is never performed in isolation, but in a combination with other training types, for example, endurance, strength and power. Therefore, it is important to note the impact of trunk muscle training may be blurred by adaptation attributable to other training types. Nevertheless, Atle and colleagues do offer some recommendations. Strength and conditioning coaches should administer longer trunk muscle training interventions, above 18 sessions, and or employ short session durations, 30 minutes or less, to improve lower limb muscle power, linear sprint speed, and change of direction/agility. However, longer sessions above 30 minutes at a frequency of twice per week appear more effective to improve sport-specific performance in athletes. And that concludes the recommendations. Thanks for listening, folks. See you next time.